In this video, you will learn how to identify if ratios are proportional. So we're going to be moving on from writing just ratios to looking at proportions. So a couple things that I want you to be aware of. We're going to start first thinking about equivalent ratios. So equivalent ratios are going to be when you have ratios that they're naming the same comparison. So those ratios are comparing things and they're naming that same comparison. So you might have different numbers, but they're equal to the same thing. So then when we have those two equivalent ratios, when we put it in an equation form, so that means it's going to have an equal sign. When you have an equal sign in between those two ratios, that's going to be stating that the two ratios are equivalent. That's what the equal sign means, that things are equivalent. We call that a proportion. So having two equal ratios and putting that equal sign in between means that it is proportional, or it's called a proportion. So with proportions, it says here that if two ratios are equivalent, they are said to be proportional to each other or in proportion. So let's take a look at an example here so you can see some numbers and what this actually means. So we're looking at these two ratios and seeing if they're proportional. So we have 5 to 6 and 15 to 18. So really, when you were doing simplifying fractions, what we're doing with this is very, very similar. Because if you have equivalent fractions, it's really the same as having equivalent ratios. Remember how we've talked about how fractions and ratios they're kind of the same. So when I'm looking at this 5 over 6 or 5 to 6 and 15 to 18, I want to look to see how did this 5 change. So when I'm going to 5 to 15, I can see that this tripled. And then if I'm looking from 6 to 18, see how this also tripled. So both of these numbers in the ratio were tripled or multiplied by 3. And just like with equivalent fractions, when I multiply the top and the bottom by the same thing, they're equal to each other. It's just scaling it up and having bigger numbers. So this is proving that these ratios are proportional. Whoops, oh goodness. I was trying to write the word yes. That they are proportional. So here are a couple more examples. Let's look at the first one together. So we're looking to see a ratio of 7 to 10. Is that proportional to 22 to 30? So if I look, let me start at the bottom for this one. From 10 to 30, if I'm looking at the change here, 10 was multiplied by 3 to get to 30. So in order for it to be proportional, the 7 would also have to be multiplied by 3. And if I do 7 times 3, it is not 22, it's 21. So I can see right there that it is not proportional. Now let's say if I really wanted to know what 7 was multiplied by to get to 22, what I could do is I could take 22 and divide it by 7. So take my calculator, do 22 divided by 7, and I would end up with a decimal. It's something like 3.14. So you can see how the top was multiplied by something a little more than 3. The bottom was multiplied by 3, which is why it's not proportional. So here's another example on the bottom. I want you to try this one on your own. So do the same strategy that I just did. Pause the video, take a few seconds to do it. Once you think you got it, turn me back on and I'll go through what you should have done. Okay, so on this one, I'm going to start on the bottom again because I noticed that when I go from 9 to 27, it's times 3. We have a lot of times 3 going on here. If I go to the top, 7 times 3, once again, is not the number that's there. It's not 24, it's 21. So if I go from here to here, I can see that that is not going to be proportional because it was not changed by the same value as the bottom was. It was again multiplied by something a little bit more than 3. So this one is also not proportional. We can also look at a story problem that has some information and see if things are proportional. So this one says, students in Mr. Howell's math class are measuring the width, which is W, and the length, which is L, of their heads. The ratio of L to W, so length to width, is 10 inches to 6 inches for Jean and 25 inches to 15 inches for Pat. Are the ratios proportional? So the ratios are already set up for you. So we have 10 to 6 and 25 to 15. So I'm going to look to see how did this change. So we are going to go from 10 to 25. So this one, I might not know what 10 times what equals 25 because it's not like a whole number like 2 or 3 or 4. So what I could do is I'm going to take my calculator and I'm going to take 25 divided by 10. And that's going to tell me what 10 was being multiplied by. So in this case, I'm going to end up with it being multiplied by 2.5, so times 2.5. So then I'm going to do the same thing on the bottom. I'm going to look to see how is 6 changed. Was it changed by the same thing? So I can either try it and do 6 times 2.5 and see if I get 15. Otherwise, I can do the same strategy as I did on the top. Take 15 and divide it by 6. And if I did do that division, yes, indeed, it is multiplied by 2.5. So the top and the bottom were multiplied by the same thing. So that is telling me that this is proportional. So to write it as a proportion, it's going to look something like this. I just put an equal sign in there. So that's what it means by making it an equation, because that equal sign's in there. And that's saying that this is a proportion. 10 to 6 is equal to 25 to 15. So another thing we could do, and we've done a little bit of this lately, is that we can make a proportion. We can write a ratio that's equivalent to it. So 11/12. Just like with equivalent fractions, I can think of a ratio that would be equivalent to 11/12. So I can multiply the top and the bottom by anything as long as I'm multiplying it times the same thing. So let's do something easy. I'm going to multiply and double the top. So 11 times 2 will give me 22. Oopsies. So 22. And then I have to do the same thing to the bottom. If I doubled the top, I doubled the bottom. So that's going to be 24. So this right here is a proportion that I just made. 11 to 12 is equal to 22 to 24. Do the same thing on the bottom. Go ahead and try and come up with equivalent ratio that would make this into a proportion. So with this one, there are a lot of different options that you can do. A lot of times I just try to keep it easy if I can do anything that I want, and I would maybe just go ahead and double it again. So one thing you might have done was double the 25 to get 50. And then when I double 18, I'm going to end up with 36. So this would be one option. You could have gone and multiplied them both by 10. So that would have given me the proportion of 250 times 180. So many options. As long as you multiplied the top and the bottom by the same thing, you would have written a proportion. So here is another word problem that we're going to do together. So it says, directions for making 12 servings of rice call for 3 cups of rice and 6 cups of water. For 40 servings, the directions call for 10 cups of rice and 19 cups of water. Determine whether the ratios of rice to water are proportional for both servings of rice. So I'm going to start out with the 12 serving one. So if I'm going to set up a ratio of rice to water, the 12 serving one calls for 3 cups of rice. So I'm going to label it because I think it helps when I set it up that I have the labels there. 3 cups of rice and 6 cups of water. And then the 40 serving one is going to be 10 cups of rice, and we have 19 cups of water. So I'm looking to see, is this proportional? So I'm just going to start with the top here. If I'm looking from 3 to 10, that one's a little bit harder again to see what was 3 multiplied by to get to 10. So I'm going to take my calculator. I'm going to do 10 divided by 3 because that's going to tell me what 3 was multiplied by. And on my calculator, I end up with 3 point, and then it goes 3. So that's 3.3 repeating. Then I'm going to go down on the bottom and I'm going to do the same thing. I'm going to take 19 and I'm going to divide it by 6. When I do that on my calculator, 19 divided by 6, I end up with 3.17 about. So you can see that the top was multiplied by a different number. It was a little bit bigger. So these are not going to be proportional because the top and the bottom were not multiplied by the same thing. So this is another word problem, and we've done a few, and this is our last one. So I want you to try this one first on your own. So you're gonna set up your ratios. You're going to check to see, are they proportional? So go ahead, pause the video, give it some thought, work out the problem, set up your ratios, check and see, use a calculator, and then turn me back on to see how you did. So here you can see that I started with just setting up my ratios. Now I decided to put the money on top and the pounds on the bottom, just because a lot of times that's how you do see it, money and then on top, and then the other thing like pounds on the bottom. Now if you reverse it and you set it up differently, that is okay for this. You're still gonna get the same answer. So if I'm starting on top here from 150 to 225, on my calculator, I just plugged in 2.25, so $2.25 divided by 1.5, and that gives me 1.5. So if I would take $1.50 times 1.5, it gives me $2.25. And then I'm going to do the same thing on the bottom. I'm going to take the 3 and divide it by 2. So 3 divided by 2 is 1.5. So that means that both the $1.50 and the 2 were multiplied by 1.5 to give me that new ratio. So that means that the bananas at Walmart and the bananas at Church Sticks, even though they're a different amount of pounds and price, they are proportional. So I can put an equal sign in there. So now you know how to look at ratios and compare them and see that if they're changed by the same amount, multiplied by the same amount, that they are equivalent, and that we can write a proportion by putting an equal sign in between them. So hopefully you know what you're doing now, and if you have any questions, make sure you ask.